When astronomers identified Proxima b, a planet orbiting the red dwarf star Proxima Centauri, located just 4.2 light-years from Earth, it sparked significant excitement in the scientific community. Its relatively close distance, combined with its location within the habitable zone of its parent star, positioned it as one of the most promising candidates in the ongoing search for extraterrestrial life. This raised immediate interest, as the planet receives a similar amount of stellar energy from its star as Earth receives from the Sun. This similarity led to the hypothesis that, under the right circumstances, Proxima b might host liquid water. On its surface, a key ingredient for life as we know it. However, this initial optimism is tempered by important caveats. Proxima Centauri, being a red dwarf, is highly active and frequently emits powerful solar flares and bursts of high-energy radiation. Such intense activity poses a serious threat to any nearby planet's atmosphere. If Proxima b lacks a sufficiently strong magnetic field to shield itself, these flares could strip away its atmosphere entirely. Without an atmosphere, any surface water would evaporate, severely reducing the planet's ability to support life. Despite these challenges, scientists recognize that the situation is more nuanced. Some theoretical models suggest that Proxima b may be tidally locked, meaning one side of the planet always faces the star while the other remains in permanent darkness. In this scenario, a narrow region known as the terminator zone could exist between the scorching day side and the freezing night side. This twilight band might maintain temperatures within a range that could support liquid water, making it a potential refuge for life. The terminator zone is more than a geographical feature, it represents a potential bastion of habitability. In this thin strip of the planet, the extreme heat of the day side and the deep cold of the night side could balance, creating temperate conditions. If Proxima b possesses an atmosphere, it might redistribute heat more evenly across the planet, possibly extending the habitable region. Should water be present, microbial life could also exist, potentially thriving in dim, persistent twilight. It's possible to imagine a landscape of rocky plains and dusty terrain, where moisture condenses in the shadows and unique life forms evolve to adapt to such an environment. This scenario has sparked both scientific curiosity and imaginative speculation. To investigate these possibilities, researchers are turning to advanced astronomical tools such as space-based telescopes capable of examining exoplanet atmospheres. These instruments can study the light from a star that passes through a planet's atmosphere during a transit, analyzing its spectrum to identify chemical signatures of gases like oxygen, methane, and carbon dioxide. These substances are considered potential biosignatures, indicators that could point to biological activity. However, interpreting these signals is complex. For example, while methane can be a byproduct of biological processes, it can also be produced by non-living geological activity, such as volcanism. As a result, any indication of life must be verified by ruling out all non-biological sources. One significant obstacle in studying Proxima b is that it does not transit its star from Earth's perspective. This prevents astronomers from directly observing starlight filtered through its atmosphere. Instead, scientists must rely on indirect techniques, such as measuring the planet's reflected light or detecting slight wobbles in the star's motion, both of which are technically challenging but still feasible. Ground-based observatories equipped with next-generation instruments are being developed to meet these challenges. These facilities will help gather more detailed information about Proxima b's atmospheric composition, surface characteristics, and possibly even its weather systems. Alongside this, other research efforts aim to detect signs of intelligent life. Radio telescopes are being used to listen for unusual or patterned signals from the Proxima Centauri system that might suggest the presence of a technologically advanced civilization. Although no conclusive evidence has been found yet, Proxima b's close proximity makes it a high-priority target for continued observation. If any form of life exists, intelligent or microbial, this planet may be where we first detect it. The search for life on Proxima b also raises deeper scientific and philosophical questions. What would life look like on a world illuminated by red light instead of sunlight? Could photosynthesis evolve to use infrared wavelengths rather than visible light? If so, alien organisms might have biochemistries very different from those found on Earth. Alternatively, life could exist beneath the planet's surface or in suboceanic environments, shielded from the harmful radiation of its parent star. Evidence from Earth suggests this is not far-fetched. Organisms known as extremophiles thrive in some of our planet's harshest environments, such as acidic lakes, deep-sea vents, and radioactive waste. These microbes survive without sunlight or oxygen, relying instead on chemical energy derived from rocks and minerals. Their existence suggests that life is far more adaptable than once believed. If Proxima b has subsurface water or geothermal activity, it might provide similar havens for microbial organisms. Though such life forms would likely look nothing like those on Earth, they could still exist. The discovery of Proxima b has also renewed interest in interstellar exploration. As the closest known potentially habitable planet, it represents a concrete target for future space missions. Some proposed concepts involve sending small, lightweight probes to the system at a significant fraction of the speed of light, propelled by powerful lasers. These probes could reach Proxima Centauri within a few decades and send back data and images from another star system. While still in the conceptual stage, such missions are under active development and could transform our understanding of the universe. Despite the excitement, scientists remain cautious. Being within the so-called habitable zone does not guarantee that Proxima b is truly habitable. Its proximity to Proxima Centauri increases the chances of exposure to harsh stellar conditions, including solar winds and radiation that could erode its atmosphere over time. Moreover, since the star is much older than the Sun, the planet may have been subjected to these harmful effects for billions of years, possibly making its environment increasingly hostile. Nonetheless, Proxima b's estimated mass about 1.3 times that of Earth suggests it may be rocky and possess a metallic core. If so, it might generate a magnetic field, which could offer some protection against cosmic radiation. In addition to Proxima b, scientists have identified other exoplanets in the Alpha Centauri system that may also have favorable conditions for life. These discoveries hint at the possibility of a nearby collection of worlds with environments capable of supporting life. As space telescopes continue to scan the skies, our catalog of exoplanets will grow, offering more promising targets and refining our criteria in the search for life. Each new discovery helps reduce the cosmic silence and forces us to reevaluate our understanding of life's possibilities beyond Earth. Proxima b, with all its unanswered questions and potential, has become a symbol of this quest. Whether or not life exists there, its mere presence expands the boundaries of what we thought possible. The interest in this planet reflects not just scientific curiosity, but a deeper human desire to connect with something beyond ourselves. To learn that in the vastness of space, we might not be alone. This pursuit is fueled not only by data and instruments, but also by imagination. It draws from dreams of alien landscapes, unseen ecosystems, and fresh beginnings under unfamiliar skies. Whether or not life is eventually discovered on Proxima b, the journey toward understanding it reinforces the notion that the universe is more than a backdrop to human existence. It is a destination, a mystery, and perhaps even a reflection of our deepest questions. As our scientific tools grow more advanced, so does our vision of the cosmos. Exploring Proxima b is just one step in humanity's larger journey toward the stars, a journey that may one day answer the age-old question: are we alone?